Now we're going to return to an example that we looked at in the previous chapter, and this example is about surveying a hotel guests when they leave, whether they are likely to return back. Okay. So yes would be likely to return, no will be not likely to return, and we looked at two different hotels, Beachcomber and Windsurfer. We wanted to see whether the proportion of guests who said they will return, pi sub 1 for Beachcomber and pi sub 2 for Windsurfer, whether those two are the same or not. So now we're going to take the contingency table approach for that same hypothesis. So here we have yes and no, and then there are two groups, Beachcomber and Windsurfer. So in general terms, what this looks like is, if you go back to the previous page, this is what the contingency table looks like. So item of interest or success, as you would say. So in the example, it is a guest saying the guest will return. And not of interest is no, I will not return. So yes and no. And then we have several groups within which you ask the same question and you have the same two possible answers. So here x sub 1 is the number of s and n sub 1 is the sample size. So and then n sub 1 minus x sub 1, that's the no answer. So n sub 2, again x sub 2, n sub 2 minus x sub 2. Then if you sum across the row, you get the total number of success is x, and n minus x is the total number across all the groups of non-success. And n is the total sample size. So this is the general contingency table format. So initially we are going to start with just two groups. So it will be 2 by 2. Then we'll extend the number of groups to more than 2, which is the next scenario. So when you have a situation in this fashion, then we can compute the overall proportion of S or success as x over n is the overall P proportion of success, and n minus x over n will be the overall proportion of non-success. Okay. Then from those overall values, we compute the f sub e, the expected frequencies. Okay. So here is your overall P bar. Okay, and 1 minus P bar will be the overall non-success. Okay, and then the f sub e will then be computed with multiplying this sample size for each group with that overall probability of success. So n sub 1 times P bar will be the expected frequency here, and n sub 1 times 1 minus P bar will give you the expected frequency here, and you do the same thing with the n sub 2, that will give you the expected frequencies for these two cases. So this is your actual frequency, and then you f sub o, observed frequencies, and then you compute the expected frequency in that fashion. Then we can compute the chi-squared value. So now let's head on to the Excel file. Okay. So here what we discussed already is presented here. Okay. So expected frequencies. So for our example, group 1 is the Beachcomber Hotel. So that's your first group. Second group is the Windsurfer Hotel guest. The item of interest here is the guest expressing a likelihood of return. So that's an item of not interest. So pi sub 1 is the proportion of guests expressing an interest for group 1. Okay. And same for Windsurfer will be pi sub 2. And the hypothesis of pi sub 1 is equal to pi sub 2, pi sub 1 not equal to pi sub 2. The observed frequencies are given for us. Okay, so these are the numbers that are given. Out of 227, 163 said yes. Out of 262, 154 said yes. So we can then compute the non-return, which will be this n sub 1 minus that. Okay. Now if you total this way like that, that will give us the total yes and total no. So now the total here is that plus that. That's your total number of observations, n. So the proportion p bar is that divided by that one. So we'll make that absolute reference. So 1 minus this p bar is this. So you can copy that proportion down here and you get 1 minus p bar. So the expected frequencies will be, you take each n here, multiply by p bar. So that's your p bar. Okay. Now if you then take n sub 1, multiply by 1 minus p bar, which is that will give you the expected frequency for no return. Do the same thing here, n sub 2 times p bar and n sub 2 times 1 minus p bar. Okay, so that will give you the so these are the expected frequencies. Now to make sure that we have computed these correctly, okay, if you sum column wise the expected frequencies, it should exactly match the sum of the observed frequencies. And if you do the same thing row wise, again the sum of the expected frequencies must match sum of the observed frequencies exactly. And of course the total must also be equal. So once we have that verified, then we can compute the chi-squared values. So chi-squared values are observed frequency, which comes from there, minus the expected frequency, which comes from here, square that, and then divide by the expected frequency. Observed frequency minus expected frequency, square that, divided by the expected frequency. And you have to do that for all the cells. So across like that and down. We'll put the border back. And if you sum all of those contributions, then you get the chi-squared statistic. Now degrees of freedom here is 1. So chi-squared alpha is chi-sq dot inv dot rt, and alpha, okay, we have to specify alpha here. Let's do 5%. Then we are ready to set up your critical value. And also note that for use of chi-squared, we need to make sure that the expected frequencies are all greater than or equal to 5. That relates to large sample size. You have to have large sample size, and large sample size is validated when all the expected frequencies are greater than or equal to 5. Now chi-squared table is chi-sq dot inv dot rt, alpha value, and degrees of freedom. So that gives you the chi-squared table value, and of course the conclusion now is reject. The proportions are not the same. If you wanted to do this with the p-value, then you do chi-sq dot dist dot rt and use the chi-squared stat, okay, comma the degrees of freedom. That will give you the p-value. Then you reject because p-value is less than alpha. and then you provide an interpretation. Okay, we have sufficient evidence to conclude that the proportion of guests expressing a likelihood of return is not the same for the two different hotels. The probability that this conclusion is wrong is 0.26%.